For thousands of years, people have looked up at the night sky and wondered, what's out there? It's a big question, and we've been trying to answer it for a very long time. Early stargazers saw the sun, the moon, and a handful of bright lights that seemed to wander among the fixed stars. They called these wanderers planets. They drew amazing star maps and told stories about constellations, connecting the dots in the sky to create pictures of heroes, animals, and mythical beasts. It was our first attempt to make sense of the vast, beautiful universe above us, using just our eyes and our incredible imaginations. Consider this: science starts with curiosity. Back then, a very popular idea was that Earth was the center of everything. It seemed to make sense, didn't it? The sun appeared to travel across our sky every day, and the moon and stars seemed to spin around us every night. This idea, called the geocentric model, placed our planet right in the middle of the whole show. People believed that the sun, the moon, all the planets, and all the stars revolved around the Earth. This was the leading scientific theory for over 1,500 years. It was a good guess based on what we could see, but as we'll find out, science is all about testing our guesses. These ancient astronomers were brilliant thinkers. They used mathematics and careful observation to predict the movements of the planets with surprising accuracy. They built incredible structures like Stonehenge in England or the pyramids in Egypt that aligned with the rising and setting of the sun on important days of the year. They created calendars based on the cycles of the moon and the sun, which helped them know when to plant crops and when to harvest them. They were the original scientists, using the tools they had to understand their place in the cosmos. Their work laid the foundation for everything we know today. But science is a process of discovery, and ideas are meant to be challenged with new evidence. As smart as these early observers were, there were some things they couldn't quite explain. For example, why did some planets, like Mars, seem to move backward in the sky for a little while before moving forward again? The old model required very complicated explanations for these strange movements. A new idea was needed, one that would simplify things and better match what we observed. This set the stage for a huge scientific revolution, a complete change in how we saw the universe and our place in it. Then came a game-changing invention, the telescope. In the early 1600s, an Italian scientist named Galileo Galilei didn't invent the telescope, but he was one of the first people to point it toward the sky, and what he saw changed the world forever. Suddenly, the planets were not just little points of light. He saw that the moon wasn't a smooth, perfect sphere. It was covered in mountains and craters just like Earth. This was a radical idea. It suggested that the worlds out there might be places, not just heavenly lights. The universe became a lot more interesting and a lot bigger, almost overnight. Galileo kept looking. When he pointed his telescope at the giant planet Jupiter, he saw something amazing. There were 4 tiny stars circling it. He watched them night after night and realized they were moons, orbiting Jupiter just like our moon orbits Earth. This was a huge discovery. It proved that not everything in the universe revolved around our planet. If Jupiter had its own moons, then maybe, just maybe, Earth wasn't the center of it all. This observation provided powerful evidence for a different idea, the heliocentric model, which suggested that Earth and the other planets actually orbit the sun. With better and more powerful telescopes, our view of the solar system expanded dramatically. In 1781, an astronomer named William Herschel was mapping the stars when he stumbled upon a faint, fuzzy object. At first, he thought it was a comet, but after tracking its movement, he realized it was a new planet. He had discovered Uranus, the first planet found using a telescope. This was mind-blowing. The solar system was bigger than anyone had ever imagined. It showed us that there could be more worlds out there, just waiting to be found if we only looked hard enough. The telescope didn't just help us find new planets, it helped us understand the ones we already knew about. Astronomers could see the rings of Saturn for the first time, not as a solid disk, but as a beautiful, complex system of tiny particles. They observed the polar ice caps on Mars growing and shrinking with the seasons. They saw giant storms swirling in Jupiter's atmosphere. Every new observation brought new questions and revealed that each planet was a unique and dynamic world. The telescope turned our solar system from a simple map of lights into a rich and diverse family of planets. As amazing as telescopes are, they can only show us so much from here on Earth. To really get to know our neighbors, we had to go there. The space age began, and we started sending robotic explorers out into the solar system. These amazing machines are our eyes, ears, and hands on other worlds. They can fly past planets, orbit them for years, and even land on their surfaces to do experiments. Think of missions like the Voyager spacecraft, which flew past Jupiter, Saturn, Uranus, and Neptune, sending back the first ever close-up pictures of these distant giants. Voyager is still traveling, now in interstellar space. Landing on another world is one of the greatest challenges in science and engineering. But we've done it. We have sent rovers, which are like robotic cars, to the surface of Mars. Rovers like Curiosity and Perseverance are rolling across the Martian landscape right now, as we speak. They are equipped with cameras, drills, and science labs to study the rocks and soil. They look for clues about whether Mars might have had liquid water in its past, and maybe, just maybe, if it ever could have supported life. These rovers are our robotic geologists, exploring a whole other planet for us. It's not just about landing either. We send orbiters to circle other planets and moons, mapping their surfaces and studying their atmospheres in incredible detail. The Cassini spacecraft spent 13 years orbiting Saturn, diving through its rings and studying its many moons. It discovered geysers of water ice erupting from the moon Enceladus and found liquid methane lakes on the moon Titan. These discoveries completely changed our understanding of where we might find the ingredients for life in our solar system. It turns out the possibilities are much wider than we ever thought. And let's not forget the incredible space telescopes that orbit our own planet, like the Hubble and the James Webb Space Telescope. By being above Earth's atmosphere, they can see the universe with stunning clarity. They have shown us weather on planets in our own solar system, and have even discovered thousands of planets orbiting other stars, called exoplanets. These powerful observatories help us understand how our solar system fits into the grander scheme of the cosmos. They are our windows to the universe, constantly showing us new wonders and pushing the boundaries of what we know. So what does the future hold for our exploration of the solar system? The adventure is far from over. In many ways, it's just beginning. One of the biggest questions we're still trying to answer is, are we alone? Future missions will focus on searching for signs of life or biosignatures in the most promising places. We're planning to send probes to Jupiter's moon Europa, which has a vast liquid water ocean hidden beneath its icy shell. Imagine if we could send a submersible to explore that dark, alien ocean. What we might find there could change everything we know about biology. The next giant leap for humanity will be sending people back to the moon, and this time, we plan to stay. Through programs like Artemis, astronauts will build a lunar base, a place where we can learn to live and work on another world. The moon is a perfect stepping stone for even bigger journeys. It's a place to test new technologies, practice for long-duration space missions, and learn how to use resources found in space. From a base on the moon, the next destination on the map becomes much clearer: the red planet, Mars. Yes, sending humans to Mars is a real goal that scientists and engineers are working on right now. It will be the most challenging journey we have ever undertaken, a voyage that will take months and push human ingenuity to its limits. But imagine the moment the first human boots touch the red soil of another planet. It would be a monumental achievement for all of humanity, inspiring a whole new generation of explorers, scientists, and dreamers. Living on Mars would mean learning to grow food, generate oxygen, and build habitats in an entirely new environment. The story of the solar system is our story. It began with curious people looking at the sky, and it continues today with robots and rockets pushing the frontiers of knowledge. The future is bright and full of possibility. We will discover new worlds, answer old questions, and undoubtedly ask even bigger new ones. The most important thing is that we keep exploring, keep learning, and keep looking up with that same sense of wonder. The universe is out there, waiting for us to discover it. So let's get to it.